everyone. On behalf of Indian National Trust for Art and Cultural Heritage, INTACH, and the INTACH Conservation Institutes, I extend a very warm welcome to our distinguished speaker, Mertah from Egypt, and everyone who has joined us for today's talk in the Conservation Insights 2020 lecture series. I'm Dr. Padma Rohila, Director ICI Delhi. Now to introduce our speaker, Mertah is a conservator at the Egyptian Museum in Cairo, Egypt, since 2011. Since 2013, he has also specialized in the use of portable X-ray fluorescence for analysis. And from January to July 2020, he was also a scholar at the Department of Environmental Sciences, Informatics and Statistics, Ca' Foscari University in Venice. He has a master's in restoration and conservation of metal objects from Cairo University and is currently pursuing a PhD on the scientific analysis of polychrome bronze statues of Osiris. We'll be hearing about this a lot in his talk. He has also been part of a number of archaeological missions, including restoration of stone objects found during the excavation at Heliopolis, Mataria, Cairo, conservation projects of the golden appliques of the chariots of Tutankhamun, the Havana project that involved restoration of wooden coffins and gold leaves, and many more. He is also involved in training and has given a number of lectures and has a number of publications to his credit. The title of today's talk is Non-invasive Analysis for the Characterization of Polychrome and Gilded Bronze Statues of Osiris, First Millennium BC. The talk will present the results of the research done in the Egyptian Museum, Cairo, on polychrome, gilded and inlaid bronze statues of the god Osiris from the first millennium BC. The choice of this deity is due to the fact that he was one of the most often represented, and dozens of thousands of such bronzes were discovered buried under the pavement of sacred spaces in various temples of Egypt. These bronzes are very often decorated with polychrome, gilding, and inlays. The statue's ornamentations have generally faded or almost disappeared due to the long stay in the archaeological ground or for other reasons, but some remains do allow us to reconstruct the original appearance. So the aim of the talk analysis is to assess the level of fragility of this remaining decoration using different examination methods. Furthermore, working on the analysis of the inlays of bronze and nature of various decoration materials, looking for clues concerning dating, provenances, and workshop practices. Before I invite Mertah to talk, may I please request all of you to mute your microphones. Please do type in your name, organization name, and your email ID in the chat box, and also your questions. We'll be taking those right at the end of the talk. So over to you, Eid, now. Thank you so much for doing this.
Thank you. Okay, perfect. Ladies and gentlemen, dear all, my name is Mertah. As Professor Padma Rohila introduced me, I am a conservator in the Egyptian Museum, Cairo. I would like to thank Dr. Padma for giving me this great opportunity to be with you today. And my subject today will focus on a large gilded and inlaid bronze statue of Osiris from Cairo Museum. My talk will be organized according to the four following points: what, how, and how, what, why, and how, and results. Restoration conservation has become, in the last decades, a proper academic discipline on its own. Our role as restorers, conservators, is not only to preserve objects for the future and to make them look good, but also to make research, to provide sources of knowledge, and to understand better the past by collaborating with other scientists, archaeologists, and art historians. A study in the field allows us to reflect on our role in society as responsible of the preservation of heritage. It also helps to take some distance with our own practice to think and rethink our methods, to theorize, and then to verify the hypotheses formulated. Our discipline includes a mixture of theoretical knowledge and practical skills together with the development of an ability to propose an aesthetic and ethical judgment. In my study, I will follow that example. Through this contribution, I am happy to present you some results of my research in the Egyptian Museum. My research focused on a gilded and inlaid bronze statue of Osiris, which we recently found in the basement of Cairo Museum. This statue didn't have any inventory number, and its provenance is unknown. It probably came from excavation of the early 20th century, and part of my research aims to suggest a possible provenance for this piece. This statue was found in the same box as other two pieces, a feather of a crown from another Osiris statue and a beard of a third statue. Since they were found in the same box, they are likely to come from the same excavation, but their dimensions don't fit, and we certainly deal with the three different statues. Their style is consistent, and they all three belong to the same phase of Egyptian history, the third intermediate period, probably around the 21st or 22nd dynasties in the early First Millennium BC. The aim of my work, first of all, was to explore non-invasive methods of analysis, cleaning, and conservation of the polychrome, gilding, and inlays of this statue. Secondly, the aim was to virtually reconstruct the original shape of the missing parts of the statue according to the piece that reached us in a better state of preservation. The aim was also to study the reasons for the loss of most of inlays and polychrome. Even deeply fixed inlays in glass, lapis lazuli, or metal have disappeared. Did this ornamentation fail because of intentional human action, or due to the effect of the corrosion or the action of the burial soil? Another proposal was to assess the level of fragility of the remaining decoration using different examination methods. Finally, my goal was to try to provide new dating and to explore possible provenance. This statue is indeed part of a big project, which I will explain later more in detail. Why did I choose Osiris? Osiris is probably the most popular deity during the whole First Millennium BC. His bronze statues are very often decorated with polychrome, gilding, and inlays. This makes this corpus a real challenge for restoration and conservation. Then, many statues were found in context, and we can reconstruct the conditions in which these pieces were kept for thousands of years. Archaeological ground, but also afterwards, museum storages. Finally, Osiris has the advantage to be represented as a human with facial features. This allows, by comparison with the art of the First Millennium BC, to associate statues together, to form stylistic and technological groups, and to suggest dating and provenance. Conservation restoration science today also includes fundamental research, as shown during the last years by the thorough researchers carried out, for example, at the Metropolitan Museum of Art, in the British Museum, and in the Louvre. Archaeologists, art historians, and conservators, restorers collaborate, work together to bring their own capacities and knowledge and to research the past. How? So for now, I will focus on the piece that I presented you from the basement of Cairo Museum. First of all, the work had to be carried on the statue itself. So I proceeded with analysis and examination to identify the nature of the alloy, to identify the nature of the inlays, to identify the type of the corrosion, and to understand the manufacturing technique. Finally, A result was, of course, the possibility to offer a display for the piece in the museum and to open the road to further research. Particularly, numerous among bronze statues of the First Millennium BC are the presentation of the god Osiris. The picture you can see here at the screen, this the condition state of the statue like we found at the basement of the Egyptian Museum, Cairo. The statue is made of copper alloy. It carries traces of gilding, Egyptian blue, and lapis lazuli. It measures 84.4 centimeters high without the crown. And with the crown, we can estimate its original dimension reach more than 1 meter high. By comparison with other statues previously studied in the US and UK, we can date our piece, like this piece, it's in the British Museum. We can date our piece to the third intermediate period, based so far not only statistic criteria, but also the chemical analysis. The statue itself. In its previous state of preservation, the statue consisted of two pieces, the legs on one part and the torso and head on the other. A close examination allowed observing that it originally consisted of one single piece cast around a core of clay. To this body were attached as separate pieces the crown, the beard, and the scepters. The statue was covered with a thick layer of corrosion, more than half centimeters, and a hard crust probably coming from the soil which surrounding the piece in its archaeological context mixed with the corrosion. The rear part of the torso is less well preserved than the front. Cavities are visible behind the right and left shoulders. The clay core of the piece is apparently of homogeneous composition. The eyes, the eyebrows, and the chin strips are cavities which still contain some inlays of Egyptian blue and lapis lazuli. The strip on the left has lost most of its inlays, while the right one still preserves 60% of it. Some gold leaves remains are visible on the lips and on the right chin of the statue, as you could see here. The beard. The statue was found together with this beard from another bigger statue. Description of piece composition. The piece, as it is preserved, consisted in two elements, the beard itself and the tenon, which once allowed fixing the statue to the chin, fixing the beard to the chin of an Osiris statue. A tenon is still inserted inside the beard upper extremity, to which it is fixed with calcium carbonate. The surface of the rear part of the beard is smooth and without decoration. The comparison with other Osiris statues from this time allows estimating the original dimension of the complete statue as 175 centimeters high. The front and lateral sides from a frame for lapis lazuli, reproducing the layout of plated locks. Analyzing the inlays of the beard using portable X-ray fluorescence revealed a very peculiar feature. They consist of a mix of lapis lazuli, semi-precious stone extracted in Afghanistan, and particularly praised by the ancient Egyptians, and of Egyptian blue. Parts of the lapis lazuli inlays are still preserved in position around 40%. The feather. This piece consisted in the proper left feather of an atrophic crown of a god Osiris statue. It's 17.4 centimeter high and made of bronze with 21 horizontal concave rows, inlaid with Egyptian blue, with calcium carbonate and red hematite. According to the analysis results for the Fizzle samples, the rear part is undecorated and smooth. On the lower left part, an irregularity in the shape probably once alloyed to fix it to the crown. The comparison with other Osiris pieces from this time alloys estimating the original dimension of the complete statue as 120 centimeters high. How were they made? The production of bronze sculpture metal statues are attested in Egypt from the time of the Old Kingdom, but only a few specimens before the First Millennium BC came to us for different reasons. First, metal can easily be reused and remelted for new purposes. Then, its state of preservation depends a lot on the environment condition in which the object stood for millenniums. Finally, the main reason might be also that private individuals and provenances centers have had access to metal statuary production on a large scale only from the third intermediate period onwards. The technique used for the production of the statue and for metal statuary in general is lost wax technique. This technique generally consists in creating a pattern of wax or a similar material and covering it with a layer of clay, but in the case of the body of the Osiris statue, one preliminary step was done. In order to save material, the wax was itself put around a core of clay. And then, covered by this supplementary layer of clay, then the piece is fired in a high temperature. This transforms the clay into terracotta and melts the wax, which flows out through some holes provided for this purpose in different spots. The hollow form, which is thus obtained inside the mold, is filled with the molten metal. After cooling, the external mold is broken to extract the metal figure. The last step will be polishing and removing of sign of the casting process. How? So I start to make some analysis in order to identify the alloy of the pieces. So I used portable X-ray fluorescence, as well as to investigate the corrosion and the soil classification formed by long burial and interaction with the surrounding environment. It was also used to identify the colored materials used in the inlays process of blue and red and white colors. I analyzed a lot of points on the statue to have an overview about the composition of the alloy. So the alloy of this statue consisted of 76.8 copper, 19.1 lead, and 2.09 tin, as well as some traces from other elements. The analysis done also for the beard and the feather, and it's almost give us the same result like the statue. The traces of gold on the face and the neck show that probably all the statue was gilded, and the traces of gold, it appears only after I start to make the cleaning of the statue in the neck and on the chest of the statue. During the removal of the crust from the surface of the statue, I found white color and black color above the surface of the statue. So I decided to stop the cleaning to understand the composition of these materials, to see which I could remove and which I could keep. From the analysis, I could identify the white color as the calcium carbonate, which was used to smooth the surface of the statue and to fix the gold sheets above it. For that reason, I decided to keep it. And the black color was also calcium carbonate mixed with sulfur corrosion. So I decided to reduce it to be in the same level of the white color. I analyzed also the inlays, which still remains in the right strip of the chin. And as we can see in the result, it's made from lapis lazuli. Both of these samples applied above the inlays parts of the beard, and as could be seen here also from the elements, it's made from lapis lazuli, like the statue, not glass. X-ray diffraction done to categorize the whole chemical composition of the corrosion of the soil of the pigments, blue, red, and white, as well as of the core of the statue. I don't know, I'm seeing red line on the screen. I don't know why.
You've just clicked, there's a whiteboard feature right at below. I think you clicked on the stylus there. So it's okay. I mean, stereo.
It's okay, you can see it, or it's okay?
Yeah, it's okay. I think
okay.
you go there and remove it.
X-ray fluorescence and X-ray diffraction analysis for the blue color in the statue, for the blue color under the inlays of the beard, and for the blue color in the crown feather, revealed that the blue color which used in the three objects is Egyptian blue, where it was called by this name because the ancient Egyptian made it thousands of years ago. It's known chemically as a calcium copper silicate. But the presence of Egyptian blue under the stone of lapis lazuli is an interesting thing, as it is a valuable material. So the question here is why it was used under the inlays with lapis lazuli or blue materials in general, like glass. I'm going to answer that question later. As well as we can see in the pattern of the X-ray diffraction, a high percentage of the organic material. That's why I decide to analyze this piece again. For the white color in the cavity of the head of the statue, on the feather inlays, and on the top of the tenon of the beard, all the analysis done using portable X-ray fluorescence and X-ray diffraction gives the same results, which are calcium carbonate. But the reasons for their use here are different. In the head cavity for the purpose of fixing the crown, and this was inferred through comparison with similar statue at the basement of the Egyptian museum as shown in the picture on the screen. For the tenon of the beard, it was to fix the beard with the chin of its statue. For the crown feather, it was for the purpose of inlays. The corrosion products were analyzed in the three objects, and they give the same products of corrosion components, as they were chloride components, atacamite, bartacamite, and nantucite, as well as chalcocite and cophlite. The images present here shows the patterns of X-ray diffraction and fluorescence of some of the analyzed samples of the corrosion, as well as kaolinite and quartz could be seen because the kaolinite and the highest percentage due to the burial of the statue, it was a clay soil, a quartz soil classifications. Also here you can see chalcocite, cophlite, atacamite, and bartacamite corrosions. Three samples of the inner core of the statue were analyzed from the head cavity of the statue and from the middle part of the statue to identify its components. And through the analysis, as could be seen, they consist of both the minerals kaolinite and alpite. in addition to the presence of calcite and quartz. A sample taken from the inner core from the bottom of the statue was mostly related to the soil and not from the original core. It appeared the quartz, and calcite, and very little of the halite, which were then removed to reach the original core of the statue. I analyzed the sample from the blue color on the statue, also the black color above the surface of the statue and the gold, and I found they used animal glue to fix the gold sheets above the statue and also to fix the inlays, as could be seen here during the comparison of the analysis. We made all of this analysis to find the best way to treat the objects. All the damage aspects on the statue were documented using Illustrator software before starting the restoration operation, according to the visible appearance to the naked eye, as could be seen from the front and the back side, and from the right side and from the left side. Scanning the surface of the statue using laser scan as a stage of documentation also gives the ability to understand layers of corrosion. Visual examination and examination using digital light microscope was used in order to reveal details such as grain morphology for the inlaid areas, corrosion itself, and the gold layers and micro cracks. The used device Light digital microscope allows taking high quality photos from 50 to 250x, even without direct contact with the surface of the object. The fragile state of preservation of the inlays and gold sheet required a distance of a few millimeters to be kept. And we can see here the shape of the crystals of the lapis lazuli and its fine beams, as well as the connection between the lapis lazuli and the beard itself, and the weakness that reached it, resulting in the loss of most of the parts of the lapis lazuli that was used in the inlays and the rest of to inlay the rest of the beard. Images produced using a portable optical microscope under 50x magnification, and you can see the weakness of the gilding leaves and the sequence of gilding are showing. Also for the Egyptian blue, and you can see here the calcium carbonate which used to fix the lapis lazuli. This first examination allowed determination of the different isotopes of the statue. It provides information about the corrosion layer, such as the sequence of the layer, and also another color. Here also you can see the calcium carbonate under the microscope. Egyptian blue is clearly mapped in many areas in various objects by multi-spectral imaging in IRF mode, thanks to the exceptional near-infrared luminescence emission of the pigment. From the multispectral imaging, there was a wide use of Egyptian blue as shown in the IRF image in the crown feather and the beard, while the statue eyes were filled and delineated with it in addition to the eyebrows. It can also be seen around the cheeks to connect with the chin, moreover the eyes. As you could see here, the part is contain Egyptian blue, it's appear as a white color. The other part is still contain the lapis lazuli stone, it's in dark. Examination by CT scan used to understand the manufacturing technique. The thickness of the statue alloy could be seen and the remains of the pier tenon, which is still inserted inside the statue chin, could be seen as well. Here you could see the empty space in the core. For the lower part, we found empty space inside the core of the statue. Also, we made a CT scan for the beard, but it was not clearly enough to understand the connection between the tenon and the beard. That's why we made X-ray radiography. And from the X-ray radiography, it was clearly, you can see the tenon is made separate and inserted inside the beard. Also, I made Keen's pictures with a cross section for a small piece. It was, I found it fell down from the neck of the statue. And you could see here the corrosion underneath the gilded layer. The temperature and the humidity, I measured the temperature and the humidity inside the basement for 2 years. And the lowest temperature, it was during the winter, it was 20 degrees. And during the summer, it's reached until 30 degrees. And the humidity, it was between 32 and 65 degrees. Methods of cleaning. So I used only mechanically cleaning. So it gives me the ability to make dry cleaning, and also using different materials like different brush. And also I used ultrasonic pen and micromotor to remove the hard crust from the surface. The cleaning with ultrasonic pen give me dry cleaning, and also used for a local treatment, and give me the possibility to adapt the ultrasounds level, and it's used to ground down hard corrosion product. And we should be careful not to be used on a cracked artifact before making consolidation. Cleaning with the small tools and a micromotor, micro drill, avoid scratches and waves. Also give me the same ability to make dry cleaning for local and general surface treatment, and give me a large choice of different type of bites, grinder, polisher, rubber, wool, metallic brush, diamond, and beads. And is to ground level down hard corrosion product until the limit of the original surface with a diamond bed, and to remove encrusted dust with a brush. So the result. The cleaning process shed light on a series of unexpected features. First of all, little traces of gold on different spots revealed that at least the almost complete statue was gilded. The blue inlays in the eyes and the right chin strip appeared to consist of a mix of Egyptian blue and lapis lazuli fragments. Gilded layer above the chest and Egyptian blue in the left eye, which appeared after the restoration. See the difference in the hands area and the chest before and after the cleaning. The statue from the front and the back before and after the cleaning. Vertical virtual reconstructed for the statue using Illustrator to join the piece together. So the statue, it was in 2 pieces. So to join the 2 pieces together, I used stainless steel dowels, as could be seen here. So first I weighed the upper part of the statue. It was 6 kilograms, and the lower part, it was 7 kilograms. And after that, I consolidate the core, the clay core, because it was fragile, so it should be consolidated before start to make the connection. So I consolidated using paralloid B 44, 5%. And after that, I made the hole inside the clay core. When I made the hole inside the clay core, I reached the empty space which I show you before in the CT scan. So I filled it using macroballoon with paraloid 5%, and after that I fixed the stainless steel dowel in the upper part first, and I left it for 48 hours. And after that, I fixed it with the lower part. But before that, I tried first to see if the dowels in the right position before make the final join. I used also Technomelt AS 5375. This is really nice material. We used to fix the beard of the golden mask of Tutankhamun, and also I used it in this statue to fix the edges of the statue together. For the front side, after fixing the statue, so I decided to fill the crack from the front using macroballoon with mixed with paraloid and suitable color to fill the front side of the statue. But for the back side of the statue, I left it as it is for different of reasons, because the construction of the statue is really completely stable. So it's no reason to complete the empty part and the missing part of the statue, and at the same time to give the ability for the visitors to see the core of the statue and to see the condition state of the missing part of the statue before the treatment. For the consolidation, I used paraloid B 44.5% with injection to fix the gold layer on the surface, and also to consolidate the lower part of the clay core of the statue. Mix from Polaroid B44 in toluene 5% with microcrystalline wax 5% in toluene also applied to protect the surface of the statue. Why I use mix from Polaroid B44 and microcrystalline wax? Because when I use microcrystalline wax alone, it gives me a whitish color on the surface, and when I used Polaroid B44 alone, it gives me make the surface shiny. So that's why I made the mix between both of them and give me a good result to protect the surface. The cleaning of the piece is now finished, and the result shows the three objects now in a good condition and of a high level of craftsmanship, and the objects ready for display. This picture shows the object and the statue before and after the restoration. This also shows the statue, the lower part of the statue before and after the restoration. Here as well, show the right side of the statue before and after the restoration. The left side of the upper part of the statue before and after the restoration. The lower part of the right side of the statue before and after the restoration. The left side of the lower part of the statue before and after the restoration. The back side of the upper part of the statue before and after the restoration. And this is the lower part of the back side of the statue before and after the restoration. Here also we can see the beard before and after the restoration from the front side. This is after the restoration. Here for the back side of the beard before and after the cleaning. The shape of the beard after applying the protective layer. Also, it's used the same technique for the back side. I used paraloid B44 5% mixed with microcrystalline wax. And for the front side, I used only paraloid B44 in toluene 5%, because if I use the microcrystalline wax for the pigments here, is give a little bit of whitish inside the pigments. This is the display of the object using plexiglass. This is the beard with the final display. This is the feather. Conclusion. So hopefully the current study might serve as the beginning of research not only to conservators but also to archaeologists and Egyptologists. The corpus of metal statues is indeed extremely large and still little studied. Too often, bronze statues are labeled as late period without any argumentation. The whole First Millennium BC is a rich period of production of metal artifacts, and such an approximate dating cannot be considered satisfying. It is nevertheless possible to refine such dating by proceeding with similar analysis of the alloy composition joined to stylistic approach. The result of such analysis will allow scholars to establish a good reference typology and to help them dating objects, thanks to a conformitation with pieces found in archaeological context. It may even provide clues for possible provenance if analyses are made on sufficiently large corpus of objects. As I told you before, this statue part from a big project. I am going to try to establish a method allowing to provide the dating and the provenance to bronze statues of the god Osiris by gathering the statues that could be dated based on stylistic ground and archaeological context. This project aims to provide new dating and the provenance identification criteria based on the analysis of the alloys composition and of the manufacturing process. In this matter, studying the bronze alloys of these statues and their ornamentation will bring objective and precious information on the study of this corpus. We know thousands of statues of this god from this period. Of course, I will not include all of them, but will focus on the following ones. Those that come from a well-documented archaeological context, those which provide particularly interesting information concerning their decoration or specific features. I show you here on the screen a group of 13 of them, which I'm currently studying in the Egyptian Museum. They are part of my corpus, which aims to include several dozens of pieces. This makes this research part of a larger goal, as I told you before, linked to archaeology and Egyptology, which is giving a new evidence for dating and detecting possible provenances and places of production, as well as understanding better the technologies that were at the disposition of the ancient craftsmen. Thank you for your kind attention.
Thank you very much, Eid. Thank you for a wonderful talk. We do have a few questions, so with your permission, I'll start taking those up. The first question is, how does one identify an Osiris statue? I mean, what is the history behind it? I'm sorry, I think the question is also because most of us don't know about the significance of this statue. The question is probably, how does one identify an Osiris statue? That is the first question.
Sorry, can you say the question again?
It says, how does one identify an Osiris statue? How does one identify? It's more about the iconography, the features that makes you know that it is an Osiris.
Yeah, the Osiris statues, as you could see here on the screen, from the features of the face and the position he's standing, and he gives us the ability to see and recognize if this is Osiris statue or not.
Okay, so it's the stance that makes you identify. The next question is, what were the reference standards used to determine the quantitative percentage of the elements in the object?
I didn't have a standard exactly for the production of the Osiris statues during the First Millennium BC or during the First dynasties. But when I made the analysis for the big statues, the one you have here in the middle, I found it consists of 76.8% of copper with 19.1 of lead and 2.09 of tin. And when I make a comparison with other Osiris statue, bronze Osiris statue in the British Museum, with have the same features, and I found it's have the same amount of elements, and the other one it was dating for the third intermediate period. So that's why I give provenance and dating for this statue according to the comparison with the other one. It's already knowing the dating.
Okay, thank you.
Okay, you're welcome.
What techniques were used to identify the red color?
I used both. I used X-ray fluorescence and also X-ray diffractions.
Okay.
And it was hematite.
Okay.
Iron oxide.
Okay, thank you. Was thermoluminescence used to date the ceramic core to determine the approximate date of casting?
Sorry, again?
Was thermoluminescence used to date the ceramic core, the core of the,
Okay, so this
to
is
determine the approximate date of casting?
for the casting or for the Egyptian blue?
For the casting, did you examine the core, the core that it was?
Yes, I examined the core. I take a sample from the core and I examine it using X-ray diffraction, and I found it's consists from two components. It's kaolinite and albite, so it's made from clay. And for the Egyptian blue, also I analyze it, and in the same time I use a special lens for the Egyptian blue. If I have Egyptian blue in an object or something like stone or bronze or different kinds of materials, it give me show me the white color on the picture. So all the spots with white colors will be Egyptian blue.
Okay, but was thermoluminescence ever considered as a method for analysis?
Sorry, again?
Thermoluminescence as a method, did you use that?
I used multispectral imaging, yes.
Thank you. The removal of corrosion products, did you consider the trial use of the conservation laser system? Laser.
Yes, for the laser cleaning system.
Anti-YAG 1064 laser system, conservation laser system, was that considered for the cleaning of corrosion products? Were any tests done regarding that?
Sorry, I didn't catch the question, sorry.
The question is, did you do any tests or a trial of using conservation laser system NDYG 1064?
No, but for this object, I didn't use the laser cleaning to make a cleaning using laser device. I used only micromotor and ultrasonic pen.
Was it considered? Did you consider laser cleaning, or were any trials done using that?
For the laser cleaning, it also will give us a good result, but the problem with that during that time we was not have the device of laser cleaning inside our lab. But right now we have it, but I use it right now in another object, and I try to clean a mask. It's a gilded silver mask. It's just discovered 2 years ago in Saqqara. And I try to take out the silver chlorides from the surface, but it's in certainly point it's not also give me a great result, because it give me some scratches on the gold sheet. So for during this, I prefer to use the ultrasonic pen.
Okay, thank you.
Okay. You are welcome.
Next question is, was the gilding process identified? Were you able to identify the gilding process on the statue?
Yes, for the gilding process of the statue. Sometimes in the ancient Egyptian time, she was applying the gilded layer above the statue directly. And the other time, if the statue was not have a good surface, they make the surface smooth using a layer of calcium carbonate, and after that, they using the gilded layer above that layer, and they fix it with animal glue. I identified that when I saw a white layer above the surface during the cleaning, during I take the crust out, I found a white layer. So I analyzed and I find it's made from calcium carbonate. And also when I made a cross section for the small piece from the gold, it's fell down from the neck of the statue, I found also a small layer of calcium carbonate with the corrosion.
Okay, thank you.
You
The
are welcome.
question is the beard and the feather piece, were they part of the same statue or not? And was that why they
No,
were
I mentioned,
displayed?
yes, I mentioned that in my talk in the beginning. It was not belong for each other because the dimensions of them not fit together. But I found them in the same place at the basement in the same box. So they came from the same side of excavation. And when I analyzed them using portable X-ray fluorescence, I found them they made also from the same composition of elements, almost the same. Maybe they made in the same time, but of course, for sure, it's not belong for the same statue.
Thank you. I don't see any other questions. Okay, there's one question. Were there any active copper chloride compounds observed? And how were these chloride ions, if present, removed from the surface?
I didn't found any active chloride in this statue, but if you have any active chloride, you should clean it and you should be sure it's already completely you take it out, because if you not take the active chloride out, it will be again growing above the surface. But in my case, on my statue, it was a really hard crust above the surface with the corrosion, but it was not active corrosion.
So what would you suggest for removing active corrosion chloride ions? One were to clean, what would you suggest?
Always the better solution to deal with the bronze statues or with the bronze object or the metal object in general, it's mechanically cleaning. Because the chemical product or the chemical solution you can use, maybe it will give another effect to the object and you can see it with the normal eye, and maybe in the future will make some problem. But with the mechanical cleaning, you can make a control for the cleaning, and also you can test the area you cleaned under the microscope if it's already completely cleaned from the active corrosion or not. If not, you should clean it to finish all the active corrosion on the surface.
Okay. Any other question? I don't see any. If you have, please do type them quickly. No, I don't see any other question. I think we've taken up I think all of them. So thank you, Eid. Thank you for
You are welcome.
presentation and for taking out the time for the question answers. I think we had, it was very nice, and all the best with your future analysis and your PhD. Hopefully we'll have more interesting results as you continue testing this collection that we've chosen. And hopefully we'll have a talk in the future again. If you have
Yeah, of course.
share with us.
Of course, it was my pleasure to be with you all and to present this part of my research. And if anyone have any question or need any information, he can contact me in my email. It's appear on the screen. And I will be so happy to answer any more questions or to collaborate in anything in the future.
Thank you everyone for joining us. Thank you, Eid.
Thank you so much.
Bye.
Bye.